Okay, the next presentation is OpenGeoSGB, state of art of a transition to an open source semi-automated fair-ready geological spatial data infrastructure of the Geological Survey of Brazil, presented by Carlos Eduardo Mota, me. Let's go. Our data and services, what the Brazilian Geological Service can offer to the Brazilian population for the worldwide population. This is our website, sgb.gov.br, and in the main page we see the calling for the monitoring of critical events like flooding or our products. We have we'll deliver to public geological data, geochemical, geophysical data, airborne geophysics, well log geophysics too, mineral resources, data from mineral resources, data from land management, landslides, and hazard data like geological risk, danger, and monitoring of hydrographic basins, rivers, and so on. Our expertise: geology, mineral resources, land management, and hydrology and hydrogeology. But the main question is, why change GeoSGB? The main website is geosgb.sgb.gov.br. What's the difference into the website in the left and in the right? This is our work into our company. Reason number one, this actual website, this is not an SDI, spatial data infrastructure. This website that was the main portal of data of our company, we can summarize this website into a working tree of downloads and a hub of some external services like the web maps, dashboards, some documentation, and so on. But this causes for the population a lot of trouble to find data in our website. We'll discuss this later. Reason number two, GeoSGB is an isolated database, isolated website with data. And here in Brazil, we have some actions with INGE, National Spatial Data Infrastructure, and the OneGeology. There is a hub of geological surveys worldwide providing geoscientific data. And these three databases are literally isolated. GeoSGB has his own dataset, and when we have to send data to INGE or OneGeology, we have to literally copy, construct the map, deploy the map, and we have at least 1, 2, 3 separated databases. And who guarantees that this database is equal this one and this one? This is a trouble, a big trouble on our company. And I say, why not harvest it? We create the database, create the maps, establish them on the GeoSGB, and by CSW harvest process, we can send this data and metadata even to INGE, even to OneGeology. Reason number three. We are GIS specialists, but I think there's no geologists here. But I think, do you know this standard of topographic maps, SB24ZAV1? This is, I think, so 25,000 scale map for the normal people. Where is it? I don't know. Even I'm a specialist, I don't know. Where is it? Reason number 4, the legacy data. Our legacy data now, it's hosted in proprietary software. I think you know what it is. Simple to use, simple to deploy, but hard, simple to maintain, more or less, but locks our data into a private license. We are sharing the ownership of the data with this company, and this is really, really, really bad. And this platform, this suite of software, it's not 100% compliant with the OGC standards. I don't know, I don't remember in what version all of our databases was, but even the new versions of that software doesn't comply with the OGC standards. And this is a picture that we call in our company like a Stockholm syndrome, the relationship with our company and several companies in Brazil, at least worldwide, with this company. Our managers fell in love for the kidnapper. Okay, laying foundation. We have to construct the basis, the foundation for our new SDI. Architecture, we are not excluding the proprietary software. We see this concept in the FOSS4G in Firenze, presented by a little old man from South Korea. He's the chief of the geoprocessing area of ONU. Please, I forgot the full name, his full name. But he brings, and he discussed for at least 5 years about the concept of hybrid GIS. It's the concept of a peaceful convivency and with the proprietary software, with the public software, and taking all the advantage of both. In our case, we have some workflows constructed into private software. We have workflows done in public software. Like my friend Denilson is one of the responsible of one of these FOSS4G workflows. And for the public area, for the public access of our databases, we planned to use 100% FOSS4G. And even this public area with our new SDI will provide data to the private infrastructure. Okay, and we have a wall between corporate domain to public domain, literally separated. The corporate databases, how we take the private databases and put it to public. We literally, one of our proposals is to use workflows developed on Apache Airflow, that we collect some areas of these private databases and collect them to the public area. Internally, we use PostGIS, and for the public, we are mixing PostGIS and Elasticsearch for the big data sources. And no proprietary special cartridges. We are using all the spatial extension for PostGIS, all the spatial extension for Elasticsearch. And And under this SDI, and this SDI is deployed in Kubernetes. Now we are using Red Hat OpenShift, but if we can't afford OpenShift, we have plans to deploy in OKD. This software OKD is the FOSS version of OpenShift. But if we plan to take this to cloud or use other Kubernetes solution, it fits okay. Our images, our Docker images of the SDI are hosted on this GitHub website. Let's see the timing. Okay. We choose GeoNode to provide our SDI. What are the benefits? I think I discussed in the morning with some colleagues that are present here. GeoNode has a good CMS. CMS is content management system with spatial capabilities. It has good ACL, access control language. It has a rich API. GeoNode has a very interesting API. GeoNode is hard-coded into standards. I think a lot of OGC standards that GeoNode implements. GeoNode, GeoServer, PySSW, all of them. And for me, is my favorite. It was made in Django. That explodes a lot of possibilities to extend GeoNode. But even we have some challenges and big troubles that I discussed tomorrow, in this morning. First, the scalability of GeoServer. It was a mess, a big problem. Security and compliance, I discussed it in the morning. I discussed it in Firenze. And the compliance with Brazilian laws, like INDI, that I said in previous slide. The deployment of our SDI is one challenge. This is other big challenge that we have, how to convert the legacy geological databases. And we split it into three fields: data, metadata, styling, and representation. This is our overview about the corporative databases of the Geological Survey. We use Oracle 11 with the proprietary cartridge, PostgreSQL with the proprietary cartridge, and we developed, but not published yet, a pipeline to extract this data to open format, to use the simple features. In summary, we export to the WKB using the SQL, we use the proprietary XL functions. We export into flat files. We are planning to test with GeoParquet. I think it will be nice. We check geometry, SRG, dimensions, if it's single part, if it's multi-part. Check the geometry construction because the proprietary cartridge has some caveats, some problems that we have to fix. And the geological data, the geometries for geological data are a bit complex. If we found some errors into the database, we report to GIS admins to fix them. We don't fix even if it's automatic, but we don't fix. We report, and the owner of data could fix it. And load to Destiny database and repeat to each database. 40 years, don't forget. Public data. Our public data is a download tree, an XML listed with some files. I think it's 3,000, 4,000, more or less. We have various formats: shapefiles, file geodatabase. We plan to convert to GeoPackage, geotiffs. This format, GeoSoft XYZ, It's a flat format, it's a text format, but the structure is private. We are converting to CSV or GeoPackage. We are testing yet. Sheets, Excel, CSV, and so on. We have, this is the most common formats that we work. We have to make QGIS projects for these projects, like geological mapping of Belém, with lithology, structural geology, outcrops, and so on and so on. We have to make a QGIS project, load the databases, style the databases, and save them. Export metadata, XML, export styles into SLD. In geological data, we have some problems with SLD because not all the representation are covered by the format. And at least load on GeoNode by interface, manual loading, or via API. Or if it will be okay already, the QGIS GeoNode plugin. Metadata. The legacy data set, if we have metadata, what's the format? Last week I received from a friend to check some metadata into PDF. Wait, no, stop. XML, this format, ISO 98139, okay, this one. If it doesn't have, produce metadata, fill the forms of the GeoNode forms, export XML from QGIS into the proprietary software. We can export the XML and load into GeoNode. For the new datasets, we have to produce metadata and repeat the same process. Styling, we showed this in the FOSS4G Buenos Aires. This particular chapter, because our company always uses the proprietary font files that they deliver with the software, and we had to redraw each glyph, convert to SVG. But we have we have asking for interoperability. We can take the glyphs into SVG. It works on QGIS. It works on GeoService, and so on. But in the proprietary, it doesn't because they don't support SVG. And to make this library universal, used it both proprietary and public, we used this SVG embedded into a font file, and we had to choose to OTF or TTF. OTF has a ISO, okay, it's public, but TTF we can use, but we have to take some fee to Microsoft and Apple. OTF is proprietary from Adobe, but Adobe has opened and it becomes a standard. For the continuous databases, we plan to connect an ATL process to collect from the internal database, from the corporate database, make some transformations, adjustments, and then load into a public databases. We are deciding if PostgreSQL or Elasticsearch. Airflow will do a great job for this because we are using it on the IS Agro project that I presented yesterday. Can GeoNode be fair? This is a good question. I think that all of these boxes, I think GeoNode fits, not all, but I think except one or two or three, the GeoNode could attend all of these premises for the fair data. But it's another discussion. Some screenshots, some screenshots of our system. There's not so many surprises because everybody knows how GeoNode looks like, but we are discussing some geological details on GeoNode. This is the first version. We produced it into GeoNode 4.1. We tried to reproduce the static website into GeoNode, and it fits very well. Oh, this is a geophysical data, gravimetry. This is a raster, one band raster, no problem. I think 16-bit of cell. This is this database has a special particularity because this symbology was extracted from another proprietary software, GeoSoft, Oasis Montage. I don't know if you have heard about, because it's specific for geophysical, but we have to map all the symbology and extract, convert to SLAD, convert to a QGIS style, and it fits. Gravimetry, magnetometry, gamma spectrometry, and so on. We have about 11, 12 types of geophysical data. Geological data. Let's discuss about it. Some caveats. This guy here is our main problem to represent geological data, because some symbology that we apply to this type of data, the SLD format doesn't fit very well. But we plan to use as is, and we can share the style files, and the Geological Survey uses to make this with the proprietary .lir, and now they are delivering QML2. But for SLAD, we have some problems. We prefer to deliver as is. We can deliver the option to apply the symbology on QGIS or ArcGIS and so on. But in this here, I think it's not a map, but it's a document. But here in GeoNode, we have the chance to take an area and project and make a little WebGIS with all of this data and deliver to the people, like this one. Full of faults, like trust faults, I think so. I don't forget to be a geologist. But one capability is lacking on GeoNode, and we plan to develop as a plugin, is a book download of the linked resources for the geologists. Not even only download the lithology data, we have to download all of layers. And we miss, and we plan to develop a little button download. 1, 2, 3, 4 layers. And collect all the layers of the map, and the book download. Not directly, but submit a job to salary, process the data, cut, download, zip, and deliver to the client. We have more examples of geophysical data, and the filter page. When we see the cards of the geological data, at least what OpenGeoSGB will be: a public geo open data. We plan to adopt fair data. We have some problems with vocabulary, but we are studying about this. External authentication with ORCID, because we have a big customership with researchers, and GovBR. That's the default government authentication. Unified search on documents, maps, and datasets, as GeoNode works. Integrated with the national SDI and the OneGeology by Harvard, we construct all the maps for INGI and for OneGeology, and they collect and deliver the data, no problem. No necessity to replicate data. Our GeoNode is Kubernetes-based and previews the isolation between corporative and public domains. For the work, prepare and load 4 years of data. We have a lot of time to be occupied converting, transforming, making, syncing, uploading, and so on. Some GeoNode bug fixes we have to fix because we need it to work, and if the fix is important to deliver, we deliver back. Translate GeoNode Map Story Client to Brazilian Portuguese. We are finishing. I think in the next month, in January, next year, we can release and add a pull request to GeoSolutions. Customize GeoNode images for security, as I discussed on morning, and develop some customizations. Add custom flat pages to GeoNode. Flat pages is a Django extension to make some static data and inject it into the website. Book download metadata, as I said to you. Add more resources, more data sets like well log data, that's a point with 3G. And it has public standards, I think developed by the Geological Survey of Canada. And finish the Outdoors provider for GovBR in partnership with Daniel from the Brazilian Federal Policy. Okay, I finished my third presentation. Thank you for your time.